Hello, today I will be presenting the videographic version of my HiFi thread on in-ear headphone cable measurements. So first, as a disclaimer, I do not believe in cable sound, though I do own some pretty nice cables, such as this one for my lovely Meze Elite, the premium silver cable, and also this guy here, the basic silver-plated upgrade cable, compatible with the Arya Stealth. Now, my only reason for owning these is both as headphone or audio jewelry, and in order to have these 4.4mm connections, which are both balanced in order to obtain better usage of my DAC amp's power over here. And also, I prefer them, and they work with my little headphone switch box, which I connect to my DAC amp through the 4-pin XLR, though right now I have it out of the way for these measurements and other things I want to do today. Now, when I say that I'm an objectivist in audio, that is not at all to say that I am telling you, as those who believe in cable sound, that you do not hear what you hear. No, you absolutely do perceive the differences that you perceive, but what I'm questioning is the causality of those differences. Given that, I absolutely disagree when my fellow objectivists say that you are literally not hearing what you're hearing, as that conflates some semantics regarding the term hearing. So in my case, what I am distinguishing between is the actual psychological perception of the sound entering your ears and being processed by your brain, considering all the other factors such as knowledge of what cable you're listening to, as distinguished from the actual audio signal that is entering your ears. So as a primer, let's do a simple review of what sound really is. So of course it is vibrations in the air that are impinging on the eardrum, and of course eventually going into the cochlea and inducing electrical signals in your brain that are processed. But let's say then that fundamentally that sound signal or that waveform, so for example the square wave, which I've taken off of, so all credit goes to whoever created this lovely Desmos graphing calculator demonstration, link in the description. But basically, the idea is that you can see here this function, which pretty much is able to take individual sinusoids, like this, and compose them together with different phases. So phase is when you're moving this wave left and right, and then the sum of those together come to produce our final waveform. So yeah, in that regard, think of sound ultimately as being a superposition of these various frequencies of sinusoids. And given that, we can actually represent that in what's called the frequency domain, where you are putting the frequency of the individual signals on the x-axis. And what that looks like is like so. So for example, here I'm playing the first part of my favorite recording of Mahler 5. And now you can see all these harmonics that are being decomposed. So this is a frequency content of the sound here. In this case, it doesn't tell us anything about the specific phase response. Mind technically the cochlea, so that basically the snail spiral in your ears is already doing a kind of frequency decomposition such that each neuron is only experiencing a small filter or portion of the frequency band and then sending those into your ear. So your actual brain is not directly receiving the oscilloscope waves so much as the equivalent of a spectrogram. So my original video was in response to Wave Theory's video, where his entire argument was effectively predicated on the assumption that human hearing follows a similar form of pattern recognition to visual processing, but that pattern recognition seems to assume that what our brain is processing is directly this oscilloscope waveform in the time domain. Whereas, at least from what I understand of human hearing, technically what it's seeing is rather thanks to the cochlea and how it's spreading out the frequencies of the sound. We're rather receiving this information here. And this information excludes the phase response information that is contingent upon causing this waveform to look different even for the same frequency content. So going back to causality, would you not agree with me that the reason for some people hearing differences between cables is either of physical nature, meaning that the audio signal, so this waveform here, is actually changing depending on which piece of gear you're running that audio through, as opposed to psychological, as a result of expectation biases or other perceptual biases due to knowing what you're listening to. So, say what cable or what DAC and amp you're listening to, or other social expectations from having already heard people claiming these differences exist. Thus, today I'll be showing you my personal method for testing whether this signal here is actually being changed at all. So one way of doing such a test is to measure and compare the transfer function of that given playback system, including the cable. And the output of that measurement is what we call a frequency response measurement, though in this case, transfer function, meaning that it shows you what are called linear distortions, or changes in tonality, or the amplitude and phase of different parts of the audio signal. So in a theoretically perfect environment, at least for a plain cable measurement, you would expect a perfectly flat line. But here, I am also having the filtering done by the shape of my own ears, as well as a coupling between the headphone, driver, and pads with my head. And that causes this specific shape. Then, taking this headphone, for example, one can see that if we were to, for example, take this flat region as reference, then what is happening to the audio signal is that within these frequencies between 600 and around 6 kilohertz, we are receiving a relaxation in the amplitude of those sinusoids. So basically you would see a bit of a dip within the spectrogram as it reaches your ears, and that would also change the waveform. But, as you'll see, I was not able to measure any such differences. Now here, you might see slight volume differences at least. Otherwise maybe small perturbations, which I would rather attribute to frequency response changes from the ear pads and headphone driver moving with respect to your own ear amid the act of switching out those cables. And this would be even more egregious for those people who conduct cable A-Bing while completely removing the headphones first, before swapping the cables. So now we'll look into my measurement methodology, and for that I use this pair of in-ear microphones that I obtained from Earfish, situated in Belgium at the University of Antwerp. I'll give you a link in the description. So I originally used these to measure my HRTF in order to basically simulate speakers in an anechoic chamber through headphones, and I can tell you the imaging experience is absolutely fantastic. But anyways, so the reason for my using in-ear measurements instead of directly measuring the electrical properties of these is mainly because, people have already done it and shown that in the audible band between 20 Hz to 20 kHz, generally, any differences, if at all, are minuscule between these different cables. So now, for those interested, I am going ahead and measuring the entire system, and for that I have indeed found the same results, that there are no audible differences. So basically, I take these, I compress the tip, like so, insert them to my ear. First, after making sure that this cable here is secured by this head strap, like so. And originally this head strap was meant to hold on to this small Hexagon ADA-17 audio interface, just connected to the mic input. But the problem with this is that this required the DAC, so the signal generator for the test signals, and the ADC for the microphone to be on different devices, and that meant that I would get inconsistent phase response measurements due to poor synchronization between samples in the measurements. So what that looks like is over here. You can see here, just between two different measurements. So I was taking measurements, and so the very first time I conducted this test, at the start of that thread in the description, I was content in seeing absolutely no audible or significant differences. So basically what I'm saying is, when an individual claims that a cable has quote-unquote more bass, or more treble, or quote-unquote smooths out the treble, or that a cable inherently has more treble as opposed to those peaks being inherent to the headphone itself, I of course call foul, and these measurements show that to claim such is absurd. So this is the difference between a 99.95% copper standard cable versus a high-end silver-plated copper premium cable. basically nothing. But I was surprised to see what I thought might have been an actual phase response difference. Whether or not that would actually be audible, then I double checked, and of course you can see here, when I was using that Hexagon interface, it turned out that I was getting absolutely huge variations in the phase response. For the same headphone, same cable, same seating. Yeah, basically my phase response measurements for this measurement session were useless due to this inconsistency, and though originally I had the false conclusion that what was rather happening was that even the smallest perturbations in the positioning of this headphone in my head might have been causing this, but it turned out that after I finally purchased a Moto M2, note that the Earfish microphones, they require plug-in power, so in this case I'm providing 4-volt plug-in power converted via the VXLR Plus in order to convert from 48-volt phantom power, as otherwise if you try connecting these microphones directly, you will not be getting a usable signal. Note that I initially purchased the VXLR Pro because it does in fact measurably have less noise in the mid-range area by almost 10 dB, but at the cost of having rather high third-order harmonic distortion. So, and that would, I believe, be due to the use of a little transformer in here for conducting the unbalanced to balanced conversion. And yeah, that basically makes it useless for the main purpose of this, which was to be able to take averaged measurements in this Room EQ Wizard. So basically, when you set this repetitions here, it will take multiple sweeps and will conduct the average in order to lower the displayed noise floor. So that noise floor is over here, that brown trace here. And I think it can kind of resolve any distortion above 10 dB below that noise floor. Otherwise, yeah, that would be capping your measurements. So any good in-ear microphone that connects well with the Moto M2 properly, is properly powered if it needs power, and has low distortion and low noise, that would allow you to conduct your own in-ear measurements, as well as guide precision EQing of your headphones. And as you'll now see, thanks to the proper synchronization between the DAC within this Moto M2 and this amp here. So basically what I'm doing is I'm outputting through the line outs at the back, connected into the balance line in. So this is a 1/4 inch TRS to 4.4 adapter, and I'm running my FiO on the line in mode in order to bypass the internal DAC. And with that, you get wonderfully consistent measurements for your phase response. And as you can see here, this is a stock cable, exact same phase response. Even, well, I haven't taken ultrasonic measurements yet. Yeah, ultrasonics are where the measurable differences might become more significant, but again, it would be absurd to believe that you can hear those ultrasonic differences. Okay, so I already have my in-ear microphones on my head, though I won't be showing my face since I'm reserving that for a shaving stream that I'm planning in the future once I get the viewership. Anyways, to start off, I'll be showing my current approach to setting a volume reference and calibrating that within the measurement application. So basically what I first do is within Room EQ Wizard, link in the description, preferences, make sure your devices are set. So Moto M series, in, out, I'll be using 192 kHz sample rates, both in order to have faster measurements and to also be able to gather some ultrasonic data, mainly for interest. And I'm making sure that the volume control input here, so this was typically, for some reason, 0.25 back when I first started using this application, but now I've set it to 1. Then I go here, so everything's connected, and right now it's the Meze Elite here. Now what I'm doing is I'm through Equalizer APO applying my special EQ profile that I arrived upon originally from trying to EQ to the headphones.com Harman target, and then basically smoothing that out as well as doing adjustments for peaks that I was personally hearing. So this is my new, well, back then, a few months ago, before I supplanted it with my actual in-ear speaker response. So this is what a 30-degree sound source would actually look like in terms of frequency response measurements. And this was the actual EQ'd result that I got. And I can tell you it does initially sound bright, but can sound wonderful with ambisonic rendering. But yeah, basically this gives me a flat basis. And now when I play the signal, so right now that should be coming out of the left driver. I take my trusty DBA, cheap $30 thing, hold it like this, position it roughly at the middle. Normally I have the end over here resting against my chest. And then adjust the volume until it registers as 100 dBA, so A weighting. Of course, ideally I would have a dedicated, though expensive, SPL calibration device that I would use directly with the in-ear microphones, but currently this is my best way for doing this, mainly for having a decent baseline when conducting distortion measurements for headphones. So in this case, because this digital attenuator happens to have around 2 dB increments, I ended up choosing a reference of 99 dBA, and with that I put on my headphones, and again, while playing that EQ profile, I conduct the same measurement, but now through the headphones. And I basically adjust the preamp directly on the Motu M2 here until I get my desired numerical value here. Then you'll notice that when I press or place my hand on a grounded device, be it the DAC amp or the Motu, the noise floor decreases. Sometimes depends on the specific measurement session. Sometimes to the point that I'm actually able to see the signal from my heartbeat being registered by the in-ear microphones from the veins or whatnot behind my ears. Here we have a better result. So here I'd switch to the right driver, and it was showing around 8 dB. So I just go to that respective preamp knob and increase it a bit. Now that we are done with setup, we can finally take a look at this cable. So again, purely as audio jewelry. Beautiful Lavricables Grand, 6N cryogenically treated copper, and I mean I'd hope that they actually did it. This is also personally the nicest looking silver cable out there. In this case, this one is actually Litz, whereas I don't think this one is actually Litz, just a bunch of silver fibers directly twisted together and then into these bundles and whatnot. But yeah, these connectors are quite beautiful. Originally I was interested in the Effect Audio Cleopatra 2, this guy here. Yeah, pretty exorbitant. Imagine having that connected to the wonderful likes of the HE1000se, but this is only for IEMs. I was considering paying for the burn-in service that they include, mainly for the gits and chiggles, but I decided that I like my cables version. Yeah, I'd rather be the one in control of what signals go through these cables. I mean, of course, they'd have probably done some basic tests to make sure that's actually working, but yep, I'm going to go ahead and measure this guy. So again, when swapping cables, I strive to minimize the amount of motion of the actual headphone itself, since that can at least cause variations mainly in the upper treble here, so like the height and depth of these peaks and dips, though again, yeah, those I consider to be very insignificant changes and certainly not responsible for things like quote-unquote increased soundstage or more holographic imaging. So yeah, with this headphone I use a technique similar to this, where I can remove it with one hand and then can place in the other cable. Fits nicely and it's gosh darn beautiful. And it feels nice. whereas with this guy, measurement consistency is a bit more difficult, where I do have to use one hand to support it, and then do a careful wiggling before I can get it out. Mind, of course, having to go a bit blind when trying to actually locate this hole. Okay, so let's start off with the stock cable here. So basically, I go over here, click measure, make sure that I'm measuring the correct side. Right now I'll start off with the left driver. Check levels. I tend to automatically do this just to always have a lower noise floor. I also want to set this here to 4M just to have a high resolution and lower noise measurement. For now I'll be using any measurement averaging. And yeah, here, since I've already calibrated my preamps to set the volume levels, now when switching to different headphones of different sensitivities, I can just go ahead and use this volume knob instead. Okay, so now after that, let's press sweep or start and hope that no one else in the family causes noise in the middle of the measurement. So here, fortunately, with this 192 kHz measurement, I can get that done within 21.8 seconds. More difficult when you're doing 8 repetitions for a distortion measurement and you have to sit still for 3 minutes. I almost forgot to first hold up this guy, little piece of acoustic foam, right next to my head. This here mainly helps with cleaning up the group delay measurements, as well as the cumulative specular decay measurements, since it seems like those within the upper mid-range tend to get dirtied by what might be room reflections rather than the actual cup's internal reflections. So that helps clean up the measurement. Also, don't forget to turn off any EQ profiles you might have enabled, at least depending on what you want to measure. Also, don't forget to set the audio interface itself to the appropriate sample rate if you want to take ultrasonic measurements. So in this case here, this is at the Nyquist frequency, and you can only measure up to half of that. So that's all set. That's my cap. Then I'll hold this up next to the left driver. Then we can press start. Okay, then how you can see here, this is all the ultrasonic response. And then to make this phase response here look better, you can go here, unwrap phase, and you can position this as you desire. Okay, then after that I like to take just one confirmation measurement, a shorter one, that will be just a few seconds. To at least confirm the consistency of the phase response measurement. So as you can see, quite consistent. And of course you'd have some expected differences from having more or less samples in the measurement. Then I'll continue on to measure the right driver and then switch to the next cable. Okay, so that's the right driver. Do note that my right in-ear microphone happens to have a nonlinearity where it has greater sub-bass roll-off compared to the left. Currently I'm using my left microphone as a reference as being likely the most accurate, given how it responds to my speaker measurements. Given that, now we can proceed to swap cables. So first, disconnect. Again, of course, let's just say that I don't have much say to those who will claim that this cable needs quote-unquote burn-in first. Color-coded, typically red means right. So, to show the process a bit, just like so. So yeah, a lot easier to swap cables with this headphone than the Meze Elite. So yeah, I did it that way in order to absolutely try to minimize any changes in frequency response simply due to the headphone moving. And finally, moment of truth. This will be the very first signal being run through this headphone. I won't even bother to play the check levels. Okay. And one more check, shorter measurement. And what do we have? Mostly identical, pretty much. The only difference here is, I guess, indeed, differences in the conductivity or resistance, causing our lovely Lavricables cable to play a bit louder. Though, I mean, the only slight possibility could be maybe slight difference in output level or resistance, mainly from this XLR as opposed to 4.4 output, but otherwise, of course, you can always just correct that volume level difference either digitally or through your DAC amp. But yeah, just look at that. So yeah, let's go here. Maybe, so right now I'm just doing this to put a vertical shift for better comparison. Oh no, I wanted a negative. Yeah, pretty much identical. Except maybe, I mean, yeah, that could just literally be the microphone moving a bit in my ears, but yeah, again, that's already looking at ultrasonic content. So yeah, if someone's claiming that a headphone is smoothing peaks, like literally making this smoother, then in my opinion that is quote-unquote bollocks, or not at all actually due to the physical properties of the cable. And same thing here with the distortion performance, basically identical. So this is the noise floor just from that 4M measurement, where I could get that a lot lower, so that this would be above the noise floor if I were to sit here for 3 minutes doing that average measurement. And yeah, here, this is for 512K instead of 4M length measurement, where you don't have as much resolution down here. But yeah, absolutely no differences in bass or whatnot. Technically I should have changed these limits to, oh no, right, distortion, it won't show you, but yeah, here, barely anything, even the subsonics, and again, barely anything in the ultrasonics. And I'll be repeating these ultrasonic measurements with this headphone's cables and my Arya Stealth's cables. Another thing again with those measurements is that despite wave theory's claim that the audible differences are rather due to phase distortions, again, you can see here between these two headphones, virtually nothing. That's for the right driver. And when wrapping the face so you can better see the higher frequency stuff, again, barely anything. I'm not sure how much proof you need that I'm taking these measurements, but I guess I'll go ahead and include more footage. So this is for the stock cable. I've already taken these measurements. Might as well take another one just so you can see that they're the same. So yeah, same cable there. Then I'll show you the swapping. Now again, since that was unbalanced versus balanced, I'm still going to need to do a volume match. Okay, so here you saw increase of basically 6 dB, and I believe that is consistent with a doubling of power. I forget, but yeah, you get the gist. That the mere act of switching from an unbalanced cable to a balanced cable obviously will increase the volume. So if you're doing A-B, then you must be absolutely certain that the impressions you are getting are not merely due to your being biased by your happening to set your volume knob a bit louder than when you were listening through the unbalanced cable. So claims such as balanced cables increase soundstage, etc., etc., I'll be much more skeptical about such, and would demand that they be conducted under more controlled listening environments. So still needs a bit more. Okay. And another shorter one to confirm the phase response. Looks good. And moment of truth compared to the stock Arya. I mean, yeah, tiny things. So absolutely nothing drastic, like some people tend to claim about certain cables. And some of these could actually be a horizontal shift, in the samples from the measurement. I suppose I'll also go ahead and compare it to the Meze cable. Again, so you see what's connected. Left driver. That was a shorter measurement. And we can compare. So that was without changing the volume knob. And you can see here. Let me also change up the scale. For a bit better comparison. So, yeah, both of these cables are slightly, or are generally around the same length. And here, all you're seeing is a slight increase in loudness, but absolutely no change in the actual tonality, nor the phase response. If I wrap that again, you'll look there. Again, I'm not using a screen capture just for convenience. And so you can see my scare quotes. So that and that. Yeah, pretty much no differences. Even up to, I mean, yeah, we can barely see much there unless I start to change this guy to 20 kilohertz apply. Okay, so that's our ultrasonic stuff. I'm pretty sure the FiO basically has the equivalent of an NOS filter, I think, in order to be able to play up to this level. And same thing with the Mo2. Well, yeah, technically because I'm using this guy's DAC, then it is in fact outputting ultrasonic content, since I have found that if I happen to have forgotten to change this guy from this point, then the measurements will in fact show the effects of the brick wall filter on the DAC's output, which would cut off at half the sampling frequency. So, yeah, that's the ultrasonic content. And yeah, even up to here, there's barely anything that's changing. And same thing, maybe with a stock cable, if I were to hide the phase so that's easier to see. Okay. Yeah, some minor changes. In the ultrasonic domain. Which again, you're not going to be hearing 40 kilohertz. And probably would barely affect the transient response. But here, between these two relatively similarly braided, even silver plated as opposed to actual solid 6N purity silver, yeah, barely anything. Okay, then we have the Meze Elite stock balance cable. So again, just confirming that what is connected to my head right now. Okay, and well, same thing with the right. Right there. So I've already taken a few measurements, and I'm just showing you again for this last shorter measurement. Same thing. Let's not forget the face. Then going to unplug this and proceed to show the swapping in of the premium cable. So as you can see, I do have to hold it a bit to prevent movement of the headphone that could affect the frequency response measurement. Okay, it's actually a bit better today in terms of being able to wiggle it loose like that. There you go. And again, those cuts, do note that those are in fact happening just by pressing that camera switch button on the Samsung app. Anyways, now to conduct a measurement. That was a quick one. Yeah, I don't know why it's being weird today, or at this moment, but yeah, you can see. Only difference. I mean, there might be a slightly bigger difference between the copper cable. Well, of course, well, one thing is that the stock cable is also longer, so in terms of general levels and resistance, we don't have the best comparison, but for tonality, let's see what happens if I lower this guy down by about that much. Well, if I match him over here, so yeah, we're just seeing like really small differences. Like, I mean, yeah, you could claim that it's getting brighter by less than half a dB, but are you really going to hear that? And again, phase response is the exact same. And again, these changes could also just be due to the microphone in my ear moving a slight bit, and also from a slight perturbation, even just from talking, of the headphones positioning. Then we have our, if we wrap the phase, should also be mostly the same, like so. And then zooming into the ultrasonics. Yeah, really barely anything. So barely any ultrasonic differences. And for those who believe that there would be differences when playing actual music as opposed to sine sweeps, at least here I'll use a multitone. So basically this will produce an approximation of audio. Right now I'll use 12 octave, and I need to set this to -5 to get a decent level that will not clip. Here I'll be playing this right now. I'm still using the Arya Stealth. Here you'll notice that when I put my hand down here, one of the main sources of noise happens to be this main stuff here. That's your 60 Hertz mains noise. Okay, let's play this. I'll save these for comparison. Okay, and then now let's compare that performance to Lavricables. I mean, let's say you can probably already trust that I am in fact swapping the correct cables. And so on. Okay. And now we'll play that generator again. Theme settings. Turn this guy back on. Okay, technically you shouldn't be looking at where this curve here is not relevant. Okay, so basically look here, and what you see is the noise floor of that measurement. Again, ignore this curve, since basically what it displays there will be whatever you were currently selecting within this measurement window. As you can see. But now, switching to the quote-unquote cheaper cable from Meze for the Arya Stealth, this upper manifold here is the equivalent of what happens when you play pink noise spectrum multitone. So again, this multitone here is approximating a complex signal like music, and at best this might be approximating the sound of an organ. And over here, anything above that noise floor is called intermodulation distortion. So distortion caused by having multiple tones playing at the same time. And as far as I can tell, most certainly your cable is not going to be introducing that. Or cables do not really have those kinds of nonlinearities as opposed to the actual headphone itself. So now, comparing it to the Lavricables, as you can see, this is just that's basically showing the maximum values that were detected. But yeah, pretty much nothing worthwhile in terms of differences in harmonic and intermodulation distortion. But more important is to see that, yeah, despite receiving that more complicated signal, there is no difference here in the overall frequency response manifold. So at least, yeah, right now this is the best that I can demonstrate for you, that most likely the sound, the audio that is going to your ears between these different cables is virtually identical within the audible frequency band. But again, if you still hear differences, that's not bad, so long as you know what's actually causing it. And again, I still absolutely love the look and feel of these nice cables. It's just that I currently do not believe, and neither do I hear, any special differences or like increased clarity or soundstage. And neither do I expect to. Okay, so after all those measurement results, I finally, of course, did some quick A/Bing between these cables. That and the stock cable. What a mess. Anyways, so at least today for this quick session, my choice of recordings was these two through Adagio, Takashi Yoshimatsu Symphony No. 5, particularly around the first two movements, so yeah, it starts off quite nice and big. And then starting from 50 seconds and on, you can focus on more of the details of the imaging. Say, for example, with my ears, the frequency response through these headphones happens to cause some sounds to actually have differences in height, which in my opinion is actually, with respect to music mixed for speakers, like these guys here, Genelec 8341A, is in fact an imaging distortion. Let's just say that, indeed, my personal finding, these cables do basically sound identical. If anything, possibly indeed, as measured around 0.3 or 0.4 dB louder through this cable. So, I mean, yeah, of course, you're using a better conductor, but at this point, in terms of transfer function, as I'd already shown, all you're gaining is a bit more volume, which you can obviously change using the amp or digital controls. Well, in this case, maybe to decrease the volume. So, yeah, they're basically both just as textured. Also, like, around here, around 50-second, this area, you can listen out for the piano on the very left and right. For my ears, it sounds a bit, yeah, basically around where the driver is, but around the lower part of the driver. And same thing with the cellos or whatnot that come from the right afterward. I mean, yeah, I don't hear any day and night differences in wideness or anything that is reliable within the 15 seconds or so that it takes me to switch between cables. And likewise, those places where I hear something sounding from the upper left or right above my head, yeah, no differences between these cables. And likewise, this is also another of my favorite recordings for Brahms. Yeah, mainly focusing on the start of the first movement, again, for my personal ears, and as corroborated by measurements, I'm really not hearing any advantages, and I'm not expecting any. So given this, how do you actually, objectively and immediately audibly, change the sound? That is, without having to switch between different headphones, or, for some people, playing with different DACs and amps, which again, if they measurably have the same transfer function, I would not expect them to sound any different. My answer is through EQ and ESP. So now, there are many different reasons why some people may be against EQ. Maybe their past experiences using an existing preset didn't sound very nice to them. Of course, that's all a matter of preference. But again, you don't necessarily have to use EQ to directly EQ to the Harman target as measured by a specific test head. You can at least try to use EQ to correct things such as peaks, like here. For my ears, I happen to both hear and measure the 6 kHz peak, or this general elevation, which I found was in fact dirtying the sound, making things sound less clean. And when EQing this down, using what's called a peaking filter, so in this case you would, in Equalizer APO, unfortunately only available for Windows, this is called parametric EQ, for those who don't know, then I'll just simply add this guy. Looking over here, it is about 5 dB, minus 5 dB. So that shows up there. Then you would set the Q factor in order to control how wide this is. In this case, 10 seems okay, but for example, if you set it to 2, it will be very wide. But yeah, in this case, what I personally did was, in combination with headphones.com's Harman target measurement, I then took that measurement and took my in-ear microphone measurements in order to create a much smoother response. And here you can see this, basically dead flat up to this point here. And then here I decided, because at the time when I was listening to sine sweeps, so you can Google sine sweep for what that is and hear one for yourself, I was already finding that this here was perceptually flat enough, so I didn't want to EQ anything there. But this was the area where I was hearing significant peaks that were dirtying my music, so I EQ'd this down. And that was achieved using this profile. Now, this profile here technically originates from you can see I did a whole lot of experimenting, many hours of listening mainly to sine sweeps and pink noise. But yeah, the big idea is, after originally starting off with a graphic EQ, I converted that into a parametric EQ and also did some further adjustments, finally arriving on what I call the V3 PEQ. And yeah, you can see here many filters. Performance-wise, as you can see, at least the software is barely predicting any latency, just maybe some stuff, microscopic stuff, for initialization time and CPU usage. Now, you may be afraid that using quote-unquote too much EQ, well, in this case, I think all that's really happening digitally is basically these are digital functions, digital Gaussians that are being added together and forming this shape, which then runs into a certain filter. I forget whether it's FIR or IIR, probably FIR, for equalizer APO, or basically minimum phase. And what that minimum phase means is that the addition of these filters does induce phase distortions, but in this case, what's actually happening is a phase correction. So you can see here, we have these nonlinearities in the phase. So basically, if you're afraid that EQ hurts sound quality, or due to quote-unquote ruining the phase response, you can actually see here, this nonlinearity is fixed using this EQ. And that's because this minimum phase, and I guess I'll leave you to Google more about that and why this is happening. So yeah, and that also improves the step response. So we started off here where the step response would be predicted to be dull. So at least currently my theory, and maybe also solder dudes on DIY Audio Heaven, is that looking at the step response can give one an idea of at least what isolated transients would sound like and whether or not they would be dull. And I did in fact find that, for example, here, okay, here it's for some reason reversed in polarity. So these are my dynamic headphones, still in the $200 to $300 range. You can see that they do, personally to me, they do sound duller, technically, if I at least play certain transients or like a isolated Dirac delta function. I'll include a link in the description. Whereas the Arya Stealth here is in fact, even with a stock tonality, objectively sharper, but you can technically get it sharper yet with the help of EQ for linearizing. Furthermore, EQ does not introduce any harmonic distortion other than that related to the actual playback levels on the headphone. So in this case, particularly with the Meze Elite, you would find that normalizing around this point here for loudness levels, that EQing down this region to be flatter is for this given playback actually reducing the distortion over here. And likewise over here, from EQing up this region, we aren't actually getting that much more distortion. And even then, as you can see, this red trace here is the second order distortion, which would be less audible, and to some people, like with tube amps, might be quote-unquote euphonic, while here we have the third order distortion, which is quite low. Basically, what I'm saying is that, objectively speaking, there's absolutely no losses from EQing unless you do EQ quote-unquote wrong, whereby if you learn the correct way to do it, and I will include some links on instructions on how one may do such, you can actually substantially improve your sonic experience for a given headphone, provided that the distortion performance, say compared to the Arya Stealth, so that's for the same playback level. Here, we're getting around 10 dB higher levels of these distortion harmonics, but still very low, or probably barely audible. But yeah, the idea then is if you already start off with a fairly neutral response or something that is close to what you want to EQ toward, or if the distortion is sufficiently low enough, like for example in this case I really loved the comfort of the Meze Elite compared to the other headphones that I had tried out, as well as the sheer pad size. So you can see that compared to the HiFiMan's, very similar amount of space around your ears, then you can indeed prioritize on those particular aspects, including looks, and then EQ to your heart's desire to achieve a preferred sound signature. Though of course sometimes it may be hard to find your preferred sound signature. After that, the other option is called DSP, or in my case, binaural head tracking. Basically, what I did was I, in short, took measurements of my own in-ear response to speakers. So this is some stuff that I had taken indoors, whereby all of this stuff here is due to comb filtering from reflections within the room. So theoretically, this roughness and frequency response could be limiting the quote-unquote resolution of your playback, or could be audibly reducing the clarity of what you're hearing. So with that, what I did was I generated an EQ profile. Yeah, so here's the actual original raw outdoor measurement. So using this impulse window basically allows you to erase certain reflections, and as you reintroduce those reflections, your comb filtering comes back. So going from this, and then I would remove the reflections to help smoothen out this response at the top, and that would finally lead to this EQ profile here. So now everything's nice and smooth and consistent with what my ears actually expect from perfectly neutral speakers in a room positioned 30 degrees left and right. So for example, it so happened that that 3 kilohertz peak that I was hearing here, which is due to the ear canal resonance, and which I had EQ down over here, indeed was supposed to be EQ down. But then I did learn that my ears do in fact actually expect quite more content here. That's even compared to the Sennheiser HE1, which I happen to be able to measure here, which has a little peak at 6 kilohertz, but is technically deficient down here. Then after that, this EQ is used in conjunction with DSP software, in this case Sparta Ambiroom Sim, where I am disabling image sources. So that means I'm removing all simulation of room reflections. That way I don't get any comb filtering. And then I run this through 7th order ambisonic decoding into this software here. And with that, I'm finally able to hear a convincing speaker stereo image through my headphones. And albeit with some getting used to that extra brightness that you would actually be hearing from real speakers, finally I get a wonderfully vivid sound. For example, this recording sounds absolutely wonderful through this setup here where I'm simulating neutral speakers in an anechoic chamber, and likewise my favorite recording of Mahler 5 here sounds most similar to what I heard at Roy Thompson Hall. So on top of that, included with the Earfish kit here, yeah, so note that they are a small team in the university, so if you do manage to email them, it might take upwards of a few weeks for them to get back to you. But anyways, basically, as part of the HRTF measurement kit, you receive this IMU unit, which in conjunction with this app here, as you can see, sensing the head movements, that sends the signals to this AmbiBin software, which finally allows for a virtual rotation and automatic adjustment of that EQ profile that I showed you earlier. And with that, with these headphones, not only do you get that perfect and really clear stereo imaging, you can also literally turn your head toward the different sounds in that stereo field, positioned right out there, like currently for my ears and with my measurements, mainly between these speakers, but sometimes possibly sounding a bit beyond the walls. So yeah, at least for symphonies and other tracks, it simply sounds wonderful. Though, yeah, it may not be 100% convincing compared to, say, going to Roy Thompson Hall or Kerner Hall in Toronto for a real orchestral performance. So in conclusion, I've shown why the physical properties of headphone cables and their construction is unlikely to be the actual cause of the differences that people report between headphone cables, considering that I've shown measurably that they don't actually, or are highly unlikely to be causing any differences in the way they pass sound through them. Regardless, I do not discount that people hear the difference that they do hear between cables, just that I question the cause, whereby I believe that it is most likely to be more so psychological in origin, or likewise social, from what people have heard from others, whereby I have no problem with that and people hearing different things, so long as they understand that this is most likely the actual cause. Otherwise, that need not stop us from being able to appreciate the beauty and feel of these different cables, as well as provision of certain features such as preferred connectors, balanced power for getting better power utilization out of your amps, or appreciating the technical details of how these cables were constructed and the use of fancy materials, provided that the seller isn't actually lying to you. Even though, again, as I've shown, even through this entire system, including the headphone and my in-ear mics and my physical ears, they don't actually make much of a difference. And finally, as I've described, that if you actually do want to make a real and measurable difference, then EQ and DSP are very usable and wonderful options. Alright, thank you for your time. If you happen to find this video interesting and would like to see more content from me, including stuff about audio, antique typewriters, and classical piano performances, feel free to like and subscribe.